Me. Well, welcome to, I'm sort of the end of the day. Everybody's sort of got a little bit I guess, insulin spike. They're all going like this. Oh, like that. Anyway, welcome to this presentation. We're going to introduce the Raspberry Pi PICO. The Raspberry Pi PICO. Just remember, the key to this program, the fonts turned out pretty good. If you like this program, you got to fall asleep with your head forward like this. You can even hit the table, and that's perfectly okay. Just don't hit it too loud. Remember, if you like it, go like this. Like that. Just don't snore too loud. Now, if you don't like this program, you do sort of like this. Like that, okay? And now when I'm done, all the heads should be forward. That means you liked it, but you went to sleep. That's perfectly okay. And that is not from me. Ed Hare, W1RFI from the ARRL lab did this program, and he used this when he introduced every one of his programs. So, Ed, thank you for letting me borrow it from you for all these years. Program overview, we're going to talk about the history of the Raspberry Pi and the Raspberry Pi PICO. We're also going to overview some of the basic specifications of this device. And we'll talk about getting started with the Raspberry Pi PICO. And we're actually going to do a little sample Raspberry Pi program. And if you're wondering what that is, I'm going to try to get this out here without zapping it. And this is a Raspberry Pi PICO. You say, that's tiny. You're right, it is. That's it. This is the Pi PICO 1, by the way. I've got a 2, but I've not had a chance to play with it yet. That's the Raspberry Pi PICO. It's about the size of an Arduino Nano. And we'll run the MicroPython interpreter, and we'll run just a little sample Hello World style program. Then we'll talk about resources for you to get started. Now, I'm going to fix the fonts and the slides, the links, and when you download the slide presentation, there'll be hyperlinks in it. You'll be able to actually click on them, and it'll take you to the right website. I've got to figure out in LibreOffice how to change the color of those fonts on the hyperlinks, and I've been using it on a Mac, so I'm still used to the way Mac lays things out. I've got to figure out where to change that to a white color so you can see it. But the links do work, so you'll be able to just click right on them. It'll take you, and I tested all of them, and they do work. So we'll talk about that at the very end. Okay, let's talk about the history of the Raspberry Pi PICO. Where did it come from? How did it get here? In 2011, the first Raspberry Pi was introduced by the Raspberry Pi Foundation. It used a Broadcom processor, and the price was amazing at the time of $35. $35 for a computer? You see, Eben Upton, the designer of the Raspberry Pi, said that he wanted a computer that young people, that teenagers, elementary school children even, could experiment with and didn't have to tear up mom and dad's computer in the process. So they could simply, he wanted something that a regular television and, a keyboard and mouse could be plugged into, and these kids could experiment without messing up mom and dad's computer. That was the idea, because he mentioned the BBC Micro back in the 80s that was developed in the UK, and it was quite popular. It taught a whole generation of coders. But he wanted to bring coding back to young people, and that was how he did it. How many of you bought the very first Raspberry Pi, like 2012? I did. By the way, if you have a Pi 1, an original, which I have 2 of them, now they actually might be worth some money as a collector's item. You'll be able to get to the point before long that the price will start going up. And believe it or not, you can still buy the original Pi 1. It is still available, but as you'll see in a moment, why would you do that other than for historical purposes or to make something that's totally vintage? $35. Now, they had a version without an Ethernet connector that was $25. You got to understand, at the time when this came out, it was revolutionary. How many of you saw that little blurb in QST at the end of 2011 when it was mentioned in the Hints and Kinks section? I did. I remember it. I thought, that is really fascinating. In 2015, to be outdone, they introduced then the Raspberry Pi 2, then the Pi 3. But about the time between the 2 and the 3, the Raspberry Pi Zero was introduced. And it's used today in a lot of hotspots today. That's what's used as a Pi Zero. It's a small form factor, about 2 square inches, about this tall and about that wide. It's really, really tiny. What was really neat about it, it drew 160 milliamps of current. A regular Pi drew about 700 milliamps. So it's really handy where you need battery powered application. And they came out with a price for $5 each. They actually, I think it was the Magpie magazine, they actually included in one of the issues a Raspberry Pi Pico in the cover. They actually had it in there, and so what people were doing to make money, people are opportunists, they ran around the stores and bought up these issues of the Magpie and were selling them 2 to 3 times what they paid for them. And people bought them. I mean, they really did. So that just shows you, I guess, how the free market works. But the original Raspberry Pi was succeeded. You can see there in the various generations. It had a Cortex-A7, then it went to a Cortex-A5 III processor in Raspberry Pis 3 and 4. And then the Raspberry Pi 5 that came out just 2 years ago had a Cortex-A72 processor. That's getting very close to a smartphone. Today's modern smartphone. The Raspberry Pi 5 is quite powerful and is running about $100 now, but still $100 for a computer that, if it burns up, well, you cry a little bit, but you could get a Pi 3 or 4 for about 30 or 40 or 50 bucks. If it goes zap, well, you shed a few tears and go buy another one, It's not like a $300-500 PC. In January 2021, about the time we were dealing with all the COVID nonsense, the Raspberry Pi Foundation went into the full world of microcontrollers. Now, their Raspberry Pi devices already had one, but it was similar to that in maybe a lower-end smartphone. They decided to go, instead of a Cortex-A processor, to develop a Cortex-M processor, which is a maximum speed about 150 megahertz. They decided to go more towards the lower microcontroller end. They called it the RP2040. It was their first foray into the embedded microcontroller world. These are devices below that of what's used in a smartphone, but they're used for wireless keyboards, wireless mice. I mean, accessory, things like that. It didn't need the full horsepower of a Cortex-A device, but a Cortex-M. And typically these devices are suited for a non-OS environment. They'll typically run just one application. If you want to run an RTOS, that's what they call it, a real-time operating system, you better go to a Cortex-A processor. It can be done on an M, but it's very challenging. And so this really was more for non-operating system applications. And the price, the magic number, $5. And they introduced also the chips as well. You could actually buy the RP2040, put it in your own project, or you could buy the board, which is, let me see if I can hold it here. You could buy the whole thing right there, minus the headers, of course. But you could just buy the chip on there and put it in your own project. But you better be pretty good at soldering if you're going to do that. Most of us would just buy the board, but for convenience sake, because it's easier to work with. And for single projects or something you produce 5 or 10, it would not be economically advantageous to buy just the processor and then build your own board. But if you're producing a mass production model, then it might be worth your while. 4 versions were produced. You had the original Pi Pico, the Pico H, the Pico W, and the WH. Now, you can see the difference between the original Pico and the H was it had a header on it for the debug connector. It's JTAG. Is a JTAG debugging standard. That's the only difference. It just has that connector on it. Other than that, it's the same. The Pico W was wireless. It had a wireless internet option. And the WH, of course, the header's in a different place. You can see it there on the board. But that's the only difference, is as the debug actually has a physical connector on the board. And I think the Pico W was $7. And that's amazing you can produce it for that. Not to be outdone, they weren't done. Last year, in August, the Raspberry Pi Pico 2 came out with the RP2350 processor in it. And we're going to go over that now. Let's overview some of the specifications between the two families. Here's the original. It has a dual-core ARM Cortex-M0 processor in it. And now the chip itself has memory on it, but does not have any program memory. On the Raspberry Pi Pico board, you can see on here the program memory chip is a separate IC. So if you want to do development with the RP2040, I'd recommend you buy the board because it's already on there for you. And the solder connections are that small, you could do it, but you better have some good tools to do it. And so you're probably much better off just buying the Pi PICO board. But by the way, the RP2040 wound up going into another number of Raspberry Pi's Pico variants. I think there's about like 5 or 6 out there that actually wound up being in. And you can see the original version had about 264 kilobytes of scratch pad RAM, in other words, data RAM, 2 megabytes of program memory, and was 20. And you can see that the processor was about that wide, about that wide. It's real. Oh, here it is. I'll try to point it out if I can here on the video. I'll try to do this. It's right there. I'm trying to do it here. Right where my pen's pointing. That's the main processor. Boy, it's tiny, isn't it? That is really, really tiny. Now, it also had 20 GPIO, 40 GPIO pins. Now, 26 of those pins are multiplexed. You have a UART, which is a serial data transceiver. In the embedded world, you got to understand, the serial ports never went away. In the embedded world, they're more popular than they've ever been. They never went, in the desktop world, it's all USB. But in the embedded world, UARTs are still around, alive and well. You have 2 what's called SPI ports. That is a Motorola standard called the Serial Peripheral Interface. That has 4 pins. You have a chip select line. Let's see, you have read write. Let's see, okay, master in, slave out, master out, slave in. In other words, because in the SPI world, you got a master controller and a slave controller. This chip has 2 master controllers in it, so it can send to slave devices. And then they see a chip select line, and I believe the other is ground, if I remember rightly. You have 2 I2C controllers, a standard developed by Philips Semiconductor originally, but then they became rebranded as NXP. NXP semiconductors, and Lee will correct me, but I'm trying to remember, somebody bought out NXP, I think they're under different ownership now, but it was NXP Semiconductors back about 10 years ago. They bought out Philips Semiconductor. And then you have 8 programmable I/O ports, and then of course it's powered, the Raspberry Pi PICO, which is really, really nice. If I can hold on to this thing. Right there, a micro Type A USB port, and that's what powers it. Isn't that pretty neat? And it'll take anywhere from 1.8 volts to 5.5 volts to power it. So as I did in another program, don't hook a 9-volt battery to it. It'll say, bye, I'm done with you, and I'm on vacation permanently. And there is a chart. You can't see it real well in this, but you can see how the pins are multiplexed. For example, GPIO pin 0, GP0 on pin 1 could either be mapped to a SPI, to one of the SPI transceivers, or an I2C or a UART, depending on how you configure the chip internally when you program it. You would program those ports to those pins, because GP pins 1 and 0 would go together. And you would configure it based upon what ports you want to use. They're not all available at once. You have to choose which one you're doing on those multiplex ports. You can see down below that there's more I2C SPI ports on the left side, and on also on the right. And there's an analog to digital converter on pins 31, 32, and as well as an I2 or a general GPIO port. All of them can be GPIO ports, input or output, but but there are secondary functions depending on what you want to configure, what project you're building. You say, that's a lot. You're right, it is. But it depends on what project you want to build it for. Okay, the Pi PICO 2, I should have put these side by side in a comparison, is the RP2350. It's a dual core processor. Notice it's not quad core. This is not a smartphone level device. A Cortex A was more for smartphone type devices. A Cortex M will be under 200 megahertz clock speed typically. But the Cortex A can go up to 500, 600 megahertz, gigahertz, gig and a half. They're your high-end ARM. Okay, for those of you who don't know, ARM is an architecture developed by ARMS Holdings Limited. It was a British, they licensed the specification, in other words, the standard, if you will. And they licensed out the ARM architecture to a lot of semiconductor manufacturers. I think there's like 10 or 12 that make it, major manufacturers that make ARM processors. So the manufacturers didn't come up with the architecture. ARM's Holding Limited did. And so you have a Cortex-A, a Cortex-R, and a Cortex-M. Those are your three major categories of ARM processors today. But you can see here that this had a little higher clock speed, not much, but look at the memory, double, 520 kilobytes. It's got 4 megs of program memory. It's double. And the same dimension. The dimensions are the same. The headers are the same. But the board has a CPU that's got twice as much memory, both program and data memory, which is really, so if you're running out of space on your Pi Pico 1, you got more on the Pi Pico 2. And you can see the ports are the same. It has the same multiplex ports and the same configuration as the Pico 1, but the big difference, more memory, and program and data memory. That's your big things. Okay, getting started with the Raspberry Pi Pico. All right, here we go. Getting started is easier than you would think. The cost to start, which with a lot of hams that's important, is very inexpensive. $5 to $10. That's what it costs you. If you buy them on Amazon, they're about 10 to 12. I think it's like 14, and of course that's shipping included. Get it to your door in 2 or 3 days. Parts are available from many online vendors, including everyone's favorite, Amazon, with the, I guess they have now the electric trucks now, I suppose. Even though I see them down my road in the middle of nowhere in the afternoon, Amazon going down the road delivering packages. They even come out to my place, believe it or not, which is right before you fall off the end of the earth. So it's right before this, right at the edge. Believe it or not, I got broadband internet now. I got Spectrum. They ran fiber all out in my area. I have 300 megabits per second fiber, and they ran fiber to my house, which was amazing. But when you get $30 billion, a good chunk of that $30 billion of the of RDOF, excuse me, a Rural Digital Opportunity Fund, you're wise to spend it because it's a give me. So I'm just thankful they came out. They got me hooked up in 3 hours. They ran a fiber they ran fiber a half mile down my road, 400 feet approximately from the road over to my house. Airdropped it in 3 hours time. I couldn't believe they got it done that fast. So, yeah, but yeah, people say, well, I don't have fiber to my house. Well, sorry, that's the advantage when you went without broadband for 25 years. And then, there was and then they got a bunch of federal give me money, which we all paid for. Getting started, hardware, a Raspberry Pi Pico 1 or 2. I'd go ahead and buy the 2 if you're at it. It's the same price, maybe $2 or $3 more. Skip the Coke today at the convenience store and buy you a Pi 2. And that's what you need to get started. And also, an electronic breadboard is a really good recommendation to start with. And the Windows or Mac computer, by the way, if you're an Apple, they have the development environment is all, I'm doing this on a Mac. So that right there, but on your Windows machine, it may be just a little bit more what you're familiar with. But that's all you need, some kind of breadboard. It's not necessary, but I highly recommend it. When you buy the Raspberry Pi Pico, I recommend you buy it with the headers, with those headers right there. That's what I recommend that you buy it with. Oh, I thought I lost my microphone. Because you can buy it without the headers soldered on. They'll come in the bag, and you solder them yourself. But probably if you're starting out, I recommend you buy the ones with the headers soldered on. I've done it, but if I don't recommend it for the novice. Yes, it can be. Now, the way you can do it, I saw a video on YouTube. You put it in a breadboard socket on the board, and you just solder it to the top. You go. Now that goes pretty good. But if you don't do it that way, you will have deleterious results or deleterious effects and marginal results. Now, me, I've done enough soldering, I could do it confidently. But for the newcomer, I recommend you buy it with the headers because you're going to see in a moment why I recommend that. Getting started software. Now, you have a Python IDE, and what the Raspberry Pi Foundation recommends is Thonny, and I'm going to show you that today. But there is View Editor, which I want to try out. You can even use Visual Studio Code, but it's a little different on how you set up the Pi. And by the way, the Raspberry Pi Pico uses Python. It's an interpreter. It is not a compiled environment. With like the Arduino, it has sketches you write, which Gordon talked about in the hour before, and it compiles it down into the Arduino. You actually, you run it, compile it, load it, and see how it works. Python is an interpreted language. I wish we had Dave K2WX back, Dave Birnbaum, to do his Python workshop. That was really, really good. We got to enjoy it one year when we had a Friday afternoon workshop. Also, so that's what you need. You need some kind of a Python IDE. Thonny is, I would start with that. But if you want to branch out later, once you get some experience, get your feet wet, you can try others. Hey, if they don't work, go back to Thonny. There is two packages that you can choose from of Python interpreters. There is MicroPython, that's the official route from the Raspberry Pi Foundation. The other is CircuitPython. That was one developed, I believe, by Adafruit, if I'm not mistaken. I think they were the ones that mostly promulgated that. You say, which one is better? Each is just different. It depends on what you want to do. CircuitPython, I think, is more oriented toward some devices than MicroPython. But remember, in Python, like C++ and other languages, you have libraries. When you pull in and to write your Python program, you're going to import libraries to use their functions, or as they call them, methods in Java, see, functions in C++, or objects, if you want to call it that. That's a C++ term. And you say, well, no, I love object-oriented programming. I do too, because you could change the inside of the object. If you don't change it too much, it don't change the rest of the code outside. That's you can add functions to it, but the outside code never has to change, just what's inside. In other words, an object would be like this Raspberry Pi PICO. That'd be an object. This mouse here is an object. Each one has different interfaces. You could push data to that object or pull data from it, or both. But the beauty is you can modify the object, make it better. But if you leave the original code, it's still usable by the original software. It just wouldn't have the advanced features. Or you could write a new program and take advantage of the new features. So yeah, object-oriented programming is the way to go. I'm not against procedural programming. That's traditional C programming, but C++ is object-oriented, and Python is also. But the difference is Python is an interpreted language. It runs as it interprets as it's running. And we're going to show you that here in a few minutes. Development hardware. Here's a couple of things I found that I like. Is this little widget right here. And I got a picture on the board there. I actually took it so that way I could leave it in the program. You can buy it on Amazon from the SB Component Store, this little development board. I think this one actually came with a Pi Pico on it. Or you can buy it without it, either one. You can see here. I wish I could. You could take the Pi's in a header. But you see you got a breadboard socket. You got headers over here with power, 3.3 and 5 volts. It's got a voltage regulator on it. You also got some switches on here. And you got some LEDs on here. So if you want to build something to start up, you don't need any external parts. But you got a breadboard socket here where you put a whole external circuit and breadboard. This one I really like, and the link will be in the slides. When you download it, you can go right to it. It's like, I think, 19 bucks. That's dirt cheap. So if you bought this, and then if you buy the right one, it comes with a Pi with it. So I mean, 20 bucks in your computer to start embedded, that's supper at a restaurant. My supper cost more than that last night, to be honest with you. But I indulged, I admit it. I had chicken wings and I had chicken parmesan, so I indulged last night. But yeah, let me go ahead and I'll pass this around. There you go. Somebody wants to come get it? They can take a look at it. Just handle it by the sides if you would, please. Yeah, take your time, John. No worry. Just handle it by the sides, will you? So, and my anti-static will say thank you. Now, here's another one that I found for $9. And I'll pass that one around, too. A PICO board by Keys Studio, $9. It's got all the headers on it here. You plug in your Pi Pico. Remember I told you want the ones with the headers? I would recommend you buy the ones with the headers on it, unless you're confident with soldering. Me, I'm confident enough I could put it on another board and integrate it, and I wouldn't have any problem. But the advantage is that the Pi Pico goes up, you simply unplug it, you plug in another one, you're back up and running. Let's say your Pi Pico go one of the ports take a dump on it or whatever. Well, plug in another one, you're back up and running. And I'll pass this one around also. You can look at that. Jim, if you'll take that. And everybody can take a look at that that's here in person. Hey, trust me, I move so slow as everybody else does. We're all slow, especially this time of day. Okay, we're going to do a sample Raspberry Pi program now. This is one that I got to work in Thonny, which you can see right there. Look at this is the Hello World program. To make there's an LED on the Raspberry Pi that's actually on the board. But if you buy one of those external boards, you got some external LEDs you can use right on the board. And you just use the little jumpers that, by the way, they give you some jumpers in the box. You see them right here. You can buy more of these on Amazon or other dealers. Our favorite vendor, is it not? And so they even come, like I said, they come out to my area. But you can see here a sample piece of the Hello World program. The import command is importing two libraries called machine and time. And from machine import, that's importing a specific function or object from the machine library. And sleep is being imported from the time library. It's importing specific C++, or in this case, Python objects. My LED equals then pin is part of that function. LED is defined as pin and is being defined as pin out. So it defines that port as an outgoing port from the processor. While true is an infinite loop. In other words, it'll always be true. There's no way to break out. It will run. Let me see if I can put my mouse up here. There we go. It will run from here to here and then back to the top. It'll just continuously loop. Once it runs this part, it will run this until you stop it. But it's just a sample program. My LED.value is goes to the my LED function, which is defined as part of, which uses the pin object. My LED.value assigns 1 to that port. It turns the LED on. Sleep is 0.5 is a half a second delay. It's in 1 second increments. If it's 0.1, that's 100 milliseconds. And we'll play with this program in a minute. You'll see it. And my LED value 0 turns it off. And then, so in other words, this LED, it will blink for a half a second. It'll just blink like this. And that's a little sample program we'll show you in a minute. Now we're going to do a demonstration. I'm going to break out of that. Okay, you can see I've got the same code there, and I'm going to try to see if I can maximize that. Well, it didn't help much, but anyway, so that's the only drawback of the Mac is let me see if I can do this here now and get it down where you can see it. Oh, there it goes. All right, and okay, now what I'm going to do is I'm going to plug in the one I programmed. If I did, it'll blink. One is unprogrammed, one is programmed. All right, here we go. And I'm just scratching the surface of these devices, but I really like Python because you don't have to, the variable declaration can be done on the fly with Python, which is really a sweet deal. And with C++, you got to, it's more strict on variable declaration. Python's a little more flexible and forgiving. That's one thing I really like about it. Python has emerged as one of the most popular programming languages, not only for embedded devices, but for the desktop. Thonny, by the way, will do programs for your desktop as well as embedded devices, okay? Now what I'm going to do is I plugged in the USB port to my computer. I'm going to plug in the micro USB to here. Okay, that's the blank one. All right, that's the one I'm going to use in a few minutes. I got them mixed up when I put them in the box. I should have tagged them. Okay, maybe I erased both of them. Well, I'm going to go to the second part, and we're going to actually load this program. Oh, I'm sorry, I know what I forgot. Hang on here a second, let's do that. And, let's see, wait a minute here. Oh, that's the unprogrammed one, okay. This is the programmed one. I forgot to run the program, sorry about that. All right, now let's hit stop. Notice here that I can now get into the command line of the interpreter. Now, in the top box is your code for a program. The bottom box is your command line. See right there? Let's unplug it and plug it in again, okay? When it plugs in, it should, if you hit that, okay, it came up, just took a little longer. Let's do that again so you can see it, okay? All right, here we go. And give it a moment, let it boot up to the machine, and it should give you that text MicroPython version, whatever. And there it goes, it finally did it. All right, Let's get back down into there. I'm going to go, oh, let me hit that. Okay, there, yeah, it's a stop-start button. That's with Thonny, you got to get used to that. The stop button really is stop and start. You got to get used to that. Let's hit stop now. There it is. Notice it said MicroPython version whatever. Type help for more information. You'll see that on your computer screen. It's communicating with the PC saying, I'm ready. Let's do first the Hello World program. Let's do, should have done that. Print, parentheses. You can do single or double quotes. There is a difference the way you use that. I think if you have double quotes, you got to use single quotes on the inside. And if you make a syntax error, Thonny and other environments will tell you. It'll point blank let you know. Let's see, CQ. I'll just do this for kicks. And quote and close. And now watch what happens. See there? I wish y'all could really see that. Oh, you can, okay. Notice it printed back to the screen the command I sent to it. It went to the Pi PICO's interpreter. The interpreter ran it and sent it back to PC along the USB cable port. All right, let's go ahead and run now the program, okay? Let's go ahead and hit this button here. See the LED blinking? Isn't that pretty neat? Notice it's blinking half second on, half second off. Let's go into the program now. Let's change it. Let's do 2 seconds, just for jollies. 2 seconds each way, okay? Oh, I didn't do that right, I put 0.2. And this hit run again. See, it's on for 2, off for 2, on for 2, off for 2. Isn't that neat? All you have to do is change your source code in the top pane. You hit the execute button, that button right there executes a new code to the device. Isn't that pretty neat? And notice that once I put it on there, if I unplug this, and I'm going to try to do this without zapping it. See, it's unplugged. If I plug power back into it, and we'll wait for it to boot up. Oh, I got to start it up. I'm sorry. Okay. And let's hit the start. And let's hit that button. Okay, there we go. And there it is. Program's running. There it goes. Once you save it to the device, it's on there permanently. Again, you got to get used to Thonny, the way it works. But all right, let's change one more value just for jollies. Let's go to 0.2 seconds. If I can do this. So this time I wished I still had a bigger screen. I did 0.2 seconds. See it going bleep, 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 bleep. There you go. And that's just a sample program of what you can run on the Raspberry Pi Pico. If I turn this off, I believe it will still stay running once you save it to the device. Okay, let's try that. Notice I have closed Thonny, still running. I'm using the MacBook for power now. Program's still running. It didn't turn off because it's written to the device. And it'll just sit there and run till you shut the power off. So there you go. All right. All right. Let's get back to our presentation now. Now I'm going to show you how to do this. Okay. That's that. This is an unprogrammed Raspberry Pi. What you're going to do first, when you start, now with Thonny, it's a little different. With other environments, you have a couple extra steps. Notice you have a button on there called Boot SEL, Boot Select. What you do is, I'm going to do this. I'm going to plug because I'm a little bit clumsy. I'm going to plug that in, hold the Boot Select button, and then plug it into the computer. That's a little bit easier for me to do. But if you want to plug the cable into the end device and hold the button down on the device, you be my guest. It don't matter. Let's hold it down. You'll see come up on the PC here in a minute. Let go of the button after you apply it. Notice that this popped up. RPi RP2. That is now a bootable, it's like a bootable drive. And in Windows, it'll have a letter drive. In Mac, it'll be a folder. And as you know, Mac is based upon Linux. It'll be just like a folder. You can see here, we go over to the Finder view for the MacBook. Notice here, it's a folder. You can see it right there. It's another, notice here, if you click on it, there's 2 files in there that come preloaded. Okay. And if you get in trouble, you can actually nuke your device. You can erase it, restore it back to factory. You say, I goobered something up, I messed up, no problem. You can erase the programs on there and make it blank again. And actually, that's what this file over here is for, flash nuke UF2. All Python setup parameters are a .uf2 file extension when you set it up in the Raspberry Pi PICO. Okay. All right, let's go to Thonny again. We're going to open that up. I left my source code up there, but we're going to do this. Notice I'm going to go to the bottom here. Now, if this were other environments, you would actually take the a file called this, and I'm going to show it to you, just so you know what it looks like. Now, in this case, Kyle, when I did my virtual machines, I have now 2 2017, and I have one called data. I go into that one. I go into users. Then I have that one, and that's where I think my MacBook folder is. I think the others have. That was the way the virtual machines installed. I got VMware Fusion Player. If you're a Mac aficionado, VMware Fusion Player is the way to go. I have an app. I like eSword, a Bible study program, the Windows version. I bought the Mac version, didn't like it. So I installed a VM machine on my MacBook using VMware Fusion Player, and I have also Linux installed, a Linux environment as well. And so now I use that on Sunday for my Bible program, as I like the Windows version. So VMware Fusion Player is free of charge too, and they give you occasional updates. It's a really neat program if you're a Mac aficionado. Like I told you, Kyle, you ruined me. You did it first class, man. I'm getting more. The only thing I don't like about the Mac is the fonts and so forth. They're still real small. I'm still figuring out how to make them big for old people like me that have a hard time seeing. But up here, you can actually see it. All right, let's go to downloads. Now, I'm going to show you that file, what it looks like. Okay, if you see down here, there is this ARRL PICO. Notice the date and the day. And the British, of course, it's 2024. This this month and day. Notice this version 1.24. Notice the .uf2 on there. That is the Python interpreter from MicroPython for this version. But normally you would take that file, you could drag it to the ARRL2 folder and be installed. And you would just basically take it over and drag it like this. But I'm going to show you another way to do it as well. You drag it and drop it in there. And then what will happen is it will unboot your device and it's ready to be programmed. But I'm not going to do, I'm going to show you another way, the Thonny way, that actually may be easier for you starting out. Go to the bottom here. And you can notice this file over here called flash nuke UF2. If you mess up your device, you can drag that, click and drag that, drop it in the, if it's still in boot mode. You got to go back into boot select mode. Don't forget that. Drag and drop that folder in there. It erases your device. And it's ready to go to have another Python interpreter on it. So yeah, if you mess up, it's easy to correct. All right, let's go now down here to the bottom. Click on this. Notice I have options here for local Python. That would be for development on the computer. Install MicroPython, install CircuitPython. Thonny puts these in there for you. They actually build it into the program, which is really, really nice. And if you take updates to Thonny, you'll get the latest updated versions. Let's go ahead now and install MicroPython. Notice here you get the options here. MicroPython family. Notice those variants there. Be sure to leave it on RP2. A Raspberry Pi PICO, because those are variants using the 2040 processor, but they're different boards. They're not made by the Raspberry Pi Foundation. Always leave that RP, unless you buy one of their boards, then you would select the appropriate option. All right, now go to variant here. You need to choose the correct one on this. If you have a regular Pi PICO, use that option at the top. If you have a PICO W, use that one. If you got a Raspberry Pi PICO 2 or a 2W, choose the right variant or it won't work right. Be aware of that. Notice there are variants down there at the bottom of Adafruit's variant, and Mori's variants, the Spark Funds, WizNet. There's a lot of them out there, aren't they? So the RP2040 is not unique just to the Raspberry Pi Pico. People have taken the chip and used it in a lot of variants that are out there on the market. Let's choose PICO-WX. Notice it brought up version 1.24, and it brought up a link to the MicroPython website where the repositories are. Okay, let's hit install. Now watch what happens. Look here at the bottom, it says downloading. You'll see it coming over. It's downloading from the internet. There you go. Downloading, and it'll be done here shortly. Waiting for port, done. Isn't that pretty neat? Now you just click close. Notice here at the bottom, it's set up as a USB port connection to it. That's a Linux file structure, by the way. Dev is for devices in Linux. You guys have never done Apple or Linux before. They don't use letter drives. That's a Windows deal. As a matter of fact, the Linux and Apple people don't care for it. They don't care for logical drives at all because they can change. File structures in Linux don't change. That's one reason why but in the Windows world, you have letter drives. That's one thing about the Linux or in the Python environment you got to get used to. Python folders are a Linux structure as well. You have to get used to that. Okay. Now you can do this, start it up. Notice we got the MicroPython interpreter. It communicated back, says, I'm ready. I'm MicroPython this. I'm ready for your commands. Let's do that again. Now let me do it right. Let's see if I do a capital. Let's see what it does. Let's see if it kicks back on me. I bet it will. Well, to help my typewriting. I'm going to see if it kicks back. I bet if you capitalize it, it might. No, I guess it won't kick back. Now, see, it kicked back, gave an error. Syntax error. Now, let's go up there. Change that. Oh, sorry, I have to retype it again. We're in an interpret. This is a command line. That bottom is a command line box, just like DOS would be, similar to that. But let's type it right this time. And I will copy and paste because I'm lazy. And I don't want to bore you as much. Da-da-da! There it is. Okay, here we go. It says Darrell is homely. So, okay, now let's go up here to the top to this code up here. We're now going to, the same code we had, I had it preloaded before. We're now going to load it, okay? And I'll hold this up. It's set to the 0.2 second. I never changed that. That's now I've already started it over here. Is it run button? Isn't that pretty neat? And notice I can go in there and change it on the fly, and you just hit the play button, run the script. Boy, it's strobing real fast now, ain't it? Let's go down to 50 milliseconds, and then we're done playing. But you can see here that getting basic programs running, and there it is, it's really strobing now. I put it down to 50 milliseconds, or I tried to. If you go too low, it'll look like it's glowing continuously. But we don't have time, unfortunately, to put in a software where we actually could make it do this, pulse width modulate. I don't know, that port may not do that, but that's the next thing I'll have to play with. But if you want to use the other ports, you put in one of these little boards right here, put it in there. I could hook up to that and run it on here as well. And you put a jumper over to one of these LEDs over here. Notice LED and button is on here. You put a jumper over to the pod, you can use more LEDs. They're right on this board. Or if you want to put an LED display, put it on the board. You could put a little LCD, one of those OLED screens. Put it on there. You can interface to it, and it's programmed. I think most OLED boards are I2C or SPI. I forget which one they are. And they could be either, depending on who makes the board. Some are I2C, some are SPI. Okay. And notice again, if I close it, let's go ahead and save the changes. Still running. It's just getting power from the Raspberry Pi, from the MacBook. See, it's still running. All right. Let's bring back into the presentation. Okay, resources. Now these, I'm going to try to fix these links and make them bright, but they do work. So if you want the Raspberry Pi PICO manufacturer's website, it's up there. The Getting Started, they have a wonderful Getting Started tutorial that is, I think, a little more geared towards using a Raspberry Pi. You could use a Raspberry Pi with running Linux to program a Pi PICO. And that's what the Pi PICO Foundation, they really prefer. But they do, with Thonny, you could use a Windows machine, a Mac, or whatever the case may be. Getting Started, there's a book out there that it'll be in the links in the slides at archive.org. It's basically geared towards elementary to middle school children. It's very basic, but it's written very well. And you can download the PDF version and read that. And Seed Studio has an excellent PDF document on a beginner's guide for the Raspberry Pi PICO as well that you can also consult. Now, I recommend this video series on YouTube that Paul McWhorter did. He has let's see, toptechboy.com. I should put that in the slides too for his website as well. And he's the Bible boy as well. He has Bible lessons on one and tech lessons on the other. And it's funny, people comment, I went to watch your Bible lessons and I came over here. They wound up being a Raspberry Pi. He has a whole series on the Raspberry Pi, Raspberry Pi PICO, Arduino, and all the others. I think the Pi PICO is up to 60 lessons. They're about 20 minutes each. It's wonderful. And I will show you a glimpse of that just so you know what to look for. Okay, here we go. I want to show you that. There we are. There's Mr. McWhorter. His videos are very high quality. Now, he uses some products you may or may not buy, but he puts in nice video in there. He'll tell you get a black cup of coffee.
If I show up, okay, so it's not recognizing it.
Notice how high quality they are. He's got a camera that says view in the background. Now, let me show you a code view. He uses Thonny in his lessons. He'll take you through it, walk you through it step by step. Each episode's like about 20 minutes. So he'll tell you get you a black cup of coffee, no sweetener, no creamer, and drink black coffee with him and enjoy it. But Paul McWhorter, he's got a lot of series on his YouTube channel that they're well worth watching. All right, we'll. So yep, I gave a shameless plug for Paul. Okay. The function shift F5 worked, all right. But that link is in there for you, so you can go right to his Raspberry Pi PICO W series. He's had it running for about 2 years now. He does an episode about once a week. So he's got, I think his Raspberry Pi series is up like 100 parts. He does something a little different every week. And he lives here somewhere in Florida. You can see the nice trees in his background, you know, so. And drink your black coffee without sweetener when you do it. Okay, and we're now at the point where the end, and I'm getting done a little early, which all the heads are down, so I'm good. Okay, do we have any questions at this time? All the heads are sufficiently down. Okay. Well, that is the end of TECHCON for this year. Again, I will float to each one of you the idea that next year, and I want to take a lot of input over the next few months, do we want to combine NCOM, Aries, if you will, ACS, AUXCOM, whatever the case may be, with the technical part of the conference? And that would be for both purposes. We had 2 NCOM presentations today, which I'm perfectly okay with that. So if that is favorable to you, let me know. My email address will be in the slides. I have my card here if you want to take it with you for my contact information. And again, I'm going to try to fix this. And I use LibreOffice. I know, I should be using Microsoft Office. I guess I just haven't given it up yet. So, and I should use I got a license for it and I need to use it. But you know, get a hold of me, tell me your thoughts on it. We're also looking for a venue for next year in one of the other counties perhaps. We're going to try to start moving it around again to make it fair for more of other folks in the section so they can attend as well. So if anybody has any thoughts on venue for next year, just let me know about that. I want to thank each and every one of you for coming today, and you now can head to the house and go relax and shut your eyes and maybe take a little snooze or enjoy the rest of the weekend. Thank you very much for coming. We'll see you. It'll be this weekend next year. Oh, you can always remember it this way. It's 2 weeks after Orlando Hamcation. So when Hamcation comes, no, in 2 weeks. That's the slot we've been in since 2016, and it seems to work out well. We avoid any major ham fest too as well. So anybody have any questions? If not, We're adjourned. See you next year, 2000, for our 12th annual